Now let's do an example. A computer engineer a computer engineering student attends an electronic lab which has 20 probes, of which 3 are bad. So we have 20 probes and 3 of them are bad. This student selects 2 probes randomly what is the probability that both are bad? So here we define 2 events, event A to be first choice is bad and B is second choice is bad, and the question asks what is the probability of A intersected by B. What is the probability of A? Sorry? 1 over? 1 over 20. Any other option? Eggs? Do you have any other opinion? What is the probability that when we pick one thing, it is bad?
It's
Sorry?
there are only 3 that are bad.
Yes, so what is the probability of having them? 1 over 3?
No.
Okay. What?
3 over
3 over 20. We have 3 bad out of 20. So the probability of picking one of them is 3 over 20. Now, what is the probability that the second one is bad given the first one is also bad? Okay, I have 20 elements, right? And these 3 are bad, so there are 20. I already have taken 1 because this was A. So, what is the probability of B, the second one, to be bad if already one of them, the first one, is bad? 2/19, because I have taken 1 out, which means 19 left, but only because that one that I have taken is bad and 2 are bad, so the probability of B given A is equal to 2/19. Now, the question is that what is the probability of A intersected by B? In order to calculate what is the probability of A intersected by B, we have a formula. This is probability of B given A multiplied by probability of B. Probability of A, and this is 2/19 multiplied by 3/20, which means it is 3/190. So the probability that I pick up 2 and it is, both of them are bad, is 3/190. Any question about this example? Let's try another example. A rigid coin, a coin which is biased, we use the word also biased. A biased coin is twice as likely to come up heads than tail. So we have a coin which is kind of biased, and if I toss it, the probability of having head is twice more than the probability of having tail. If the coin is flipped, if the coin is flipped 3 times, what is the probability of getting 3 heads? Part 1. Part 2. What is the probability of event A that 2 heads occur? Okay. First, tell me what is the probability of head, what is the probability of tail? For this biased coin, what is the probability of head, what is the probability of tail? We know that probability of head is twice of the probability of tail, and we know that the probability of head plus the probability of tail is equal to 1. So we understand that the probability of head is 2 over 3, and the probability of tail is 1 over 3. In first part, it said that what is the probability of head, head, head? Which means what is the probability of head intersected by head intersected by head? If the first one is head, will it affect on the second one to be head? What about will it affect on the third one to be head? No. So it means they are independent. So it means this is equal to probability of head multiplied by probability of head multiplied by probability of head, which is 2 over 3 by 2 over 2 multiplied by 2 over 3 multiplied by 2 over 3, which is 8 over 27. Over 27. In the second part, we want to see what is the probability of A, which is having two heads. In other words, it's the probability of having head, head, tail, plus probability of head, tail, head, plus the probability of tail, head, head. Right? Now, the first one is a head. Will it affect on the last one to be tail and the middle one to be head? No. So it means that each of them is equal to probability of head multiplied by probability of head multiplied by probability of tail, plus probability of head multiplied by probability of tail multiplied by probability of head, because they are independent, plus probability of head, tail multiplied by probability of head multiplied by probability of head, which is 2 over 3 multiplied by 2 over 3 multiplied by 1 over 3, plus 2 over 3 multiplied by 1 over 3 multiplied by 2 over 3, plus 1 over 3 multiplied by 2 over 3 multiplied by 2 over 3. So it's 4 over 27 multiplied by 3, and it is 12 divided by 27, which is 4 over 9. Right? So although it's biased, although the probability of head is twice of the tail, but having 3 heads is 8 over 27, so it's less than 1 over 3. Whereas almost by half we have the probability of having only 2 heads. Now, if two events two events are mutually exclusive, it means the intersection is empty, right? So it's mutually exclusive, which means that the probability of A intersected by B is equal to 0, because the intersection is empty. The probability of empty is 0. If A and B are independent, we know that the probability of A intersected by B is equal to probability of A multiplied by probability of B. So we get that if A and B are not impossible, in other words, probability of A and probability of B are non-zero, then if A and B are not 0, is there any way that this multiplication is 0? No, it's not possible. In other words, if they are impossible and they are independent, they cannot be mutually exclusive. Then A and B cannot be mutually exclusive. In other words, I can write that independent means that not mutually exclusive. In other words, if A and B are independent and they are not impossible, there is an intersection between A and B. There is an intersection of A and B. In other words, A intersected by B is not empty. Definitely something is in there. Why? Because otherwise one of the A or B or both of them should be 0. Which means that A or B or both of them should be impossible, which is contradicting the condition that we put. So A and B independent, and A and B are not impossible, then it means that definitely they are not mutually exclusive. So you do not need to think about it anymore. This rule that I have put here in red, or the above one, is called multiplicative rule, and we want to write the general form of that, and it is generalization of the multiplicative rule. For 2 it is here. If in an event, if in an experiment, the events A1, A2 till AK can occur, then if these ones can occur, then probability of A1 intersected by A2 intersected by AK is the probability of A1 multiplied by probability of A2 given A1, multiplied by probability of A3 given A1 intersected by A2, multiplied by probability of AK given by A1 intersected by AK minus 1. And if A1 till AK are independent, then probability of A1 intersected till AK is probability of A1 multiplied by probability of A2 multiplied by probability of AK, which means it is the multiplication of PAI, I from 1 till K. Like the example that we solved here. Probability of head, tail, they are independent, so it's multiplication of each of them. Do you have any question? If you have no question, this is the end of the lecture.